Hi dear students, welcome back to my session. In our previous session, we discussed the one of the conversion technique that is non-ideal voltage source to the non-ideal current source, or we can name it as a practical voltage source to practical current source. And today we are going to be discuss one more conversion, that is practical current source to the practical voltage source, or non-ideal current source to the non-ideal voltage source. So, and in our previous session, we discussed the what is ideal, what is practical, what is the main difference between ideal and practical voltage sources and current sources. So already you know this slide. This is also comes under the same chapter, DC network theorems. Before discussing the theorems, we are going to be work it out on the some basic funda. So already we discussed the source conversion. One of the conversion we discussed. So let's see on the next conversion. We saw the slides already. So I'm moving to the directly on our slide number 22. This right already in our last class we discussed till now. Now this class we are going to be discuss this slide. So in this slide, what we are going to be converting, we are going to be converting practical current source. This is a practical current source. Let me add this word practical current source to practical voltage source. Please try to make that word, or you can name it as a non-ideal current source to the non-ideal voltage source, right? Already you know what is the ideal current source. Resistance is a infinity, means instead of the connection of this RS, there is a open circuiting. For that, RS is equals to infinity. What about the ideal voltage source? The resistance is 0. Instead of this resistance, there is a short circuit between these two terminals. If this is the terminal X and Y, in this between two terminals, it's a short circuit made. So that is that is comes under the ideal case. But now we are discussing the practical, right? While we are discussing the practical, there is some internal resistance should be present. Already you know. The source current Is, this is the Is, multiplied by the internal source resistance Rs gives the value of the equivalent source voltage Vs. While because already you know as per the Ohm's law, V is equals to IR. How the V means left side part, how the left side part is comes to the picture when the multiplication of current and resistance, then the voltage is comes to the picture, right? Here the source current is Is and the multiplied the by the internal resistance Rs. Please try to remember this wording. This should be Is only. This should be Rs only. Means source current and source resistance. The name itself saying the some books they used to write Ri, means internal resistance. RINT, R internal. They used to mention. Some books they used to mention VI, means V input voltage, and R internal voltage. Like this, they may give the these types of wordings, but you can follow any one of the wording. But the main thing is concept is very important. So here the equivalent source voltage is Vs. Already you know this is Vs. How that Vs is comes to the picture means this is a Vs. After the coming the voltage across this A and B terminals, the Vs to the comes to the picture. That is the reason I mentioned the conversion of current source to the equivalent voltage source. Right. Let me move to the next slide. This is our next slide. In this slide also I mentioned the same diagram which I mentioned in this figure 11. So here the Vs is equals to Is and Rs. In our previous slide, in our previous sessions, we discussed the complete how this derivation is came means over there, that is 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 equals to Vs by Rs. How that derivation is came in our previous session we discussed in detail within MS PowerPoint, in the MS PowerPoint, not in MS, in MS Paint or in software. But here also we will going to be discuss in detail how this Vs is equals to Is Rs derived and how this is going to be exhibited. We will discuss in detail, don't worry. So let me move that slide. In our previous slide, a previous session, we derived this formula. Where is that formula? This in previous session we derived this formula. Here also we are going to be derived this formula. How this formula is comes to the picture. Let me do that. Let me remove this erasing of this all the points. Right. Let me take screenshot. Right. For here, for the converting practical, let me write this. This practical current source to practical voltage source. So there are set of rules before we are converting this practical current source to practical voltage source. Let me add this marker over here by this color. We are doing this conversion. So from here, first you need to follow some set of rules. First, after the converting, already you know this rule, right? You know this rule. After the conversion from the vice versa, either you convert the voltage source to the current source or current source to the voltage source, whatever you may be, the output voltage and current should not be changed. Means VLIL always constant. Based on this rule, you should make the derivation of this Vs is equals to ISRS. So for that, you should make this is before writing ISRS, you should mention this is IS, this is Vs. Please try to mention this is not Vs. Sorry, try to make this part over here. Let me write this is Vs. This is Vs. Right. In our previous session for the converting of voltage source to the current source, we made some short circuit between A B. Let me change these terminals as CD. Let me change the terminals CD. This is C. This is D. Right. This is add this clearly. This is C. This is D. Right. Now, for the converting of this current source to the voltage source, there are rules. For that, you need to be find the open circuit voltage across this AB and CD. Find the open circuit voltage VOC. Already the circuit is open. In our conversion of voltage source to the current source, over there we did short circuiting of AB and CD. But here for the finding of voltage, the open circuit is enough. For the flowing of current, there is need to be some particular path should be present. But for the finding of voltage, there is a path is not required. If you have DMM for the measurement of voltage, then you can measure the voltage directly. But for the flowing of current, you require for the measuring of current, you require the any load or any closed path. Then only you can measure the current. Right? But for the measuring of voltage, always voltage can be measured in open circuit itself only, but the drop can be measured through the resistance itself. Open circuit voltage across AB, right? This is case 1. How much voltage presence between this AB? Whatever the voltage across these terminals means this, let me write this terminal is X, this terminal is Y. Whatever the voltage presence across this X and Y terminals, the same voltage will be appear across A and B, because X and Y is parallel of this A and B. If you measure DMM across this, always this is parallel to this X and Y. So hence I'm going to be finding the voltage across the X and Y. How I'm going to be finding the voltage across X and Y like this. Here my current is flowing in this path. How my current is flowing in this path? After the coming this X point, the current is going to be diverted into the two ways. One is A path, one is Y path. In the A path, the current will not flow because this is open circuit. Current always choose the closed circuit path. So in this mode, the total current means Is of current will flowing through this X and Y branch. Hope you clear. So hence, while flowing through the X and Y branch, Is in the Rs is a combination of voltage drop. The same voltage of X and Y will be appear, the same voltage across this X and Y means X and Y is a combination of Is and Rs, right? The same voltage will be appear across this in the terminals. Hence Vxy is nothing but a Voc. I can name it as a Voc of AB. Hope you clear. Hope you clear about this point. Hence my voltage across this, let me write this. Hence the voltage of Vxy is nothing but a VAB. Then Vxy is equals to VAB. Also I can write Vxy is equals to Is and Rs because the voltage drop is nothing but the combination of resistance and current. Hence the value will be how much value? Is Is Rs. Is Rs of voltage drop will be present across POC. This is case 1, means equation 1. Now as whatever you did the steps, then same steps follow for the CND. Now I'm doing the CND open circuiting of CND terminals. Then I can measure the voltage across the CND. How much voltage will be present on the DMM means the digital multimeter. The same voltage will be appear over this, right? Vs of this voltage, because there is no flowing of current through this element. Since there is no flowing of current through this element, hence there is no drop. So even the giving of Rs, there is doesn't meaning of the voltage is consuming of this voltage. That doesn't mean the resistance is consuming the voltage, because resistance when the voltage will be appear across the resistance, when the current is flowing the resistance only, the voltage drop will be appear across this resistance. Now the current is not flowing through this resistance, hence there is a no voltage drop across this resistor. So hence the total voltage will be appear across Vs. Means the output voltage is equals to the input voltage. Means the output voltage or open circuit voltage of CND is equals to supply voltage, right? Output voltage or open circuit voltage of CND is equals to supply voltage. Now let me write that point clearly. Sorry, let me change my color, right? VOC of CND in CND terminals is equals to how much voltage will be appear across the CND. Same supply voltage Vs of voltage will be appear. This is equation number 2. As per rule number this rule, so the IL should not be changed and VL should not be changed. This. So based on this rule, I am going to be equating of this both equation. Means equation number 1 is equals to equation number 2. I am equating equation number 1 is equals to equation number 2. Then let me find further step. I'm equating equation number 1 for the equivalence for the balancing circuit, or for the equivalencing of circuit. I'm going to be equating equation 1 is equals to equation 2. Then my circuit will be, then my derivation will be look like this, is equals to is equals to Vs. Hence I got this. So the voltage across this element should not be changed. What is my intention. So hence the voltage across this A and B should not change, and the voltage across this C means the same voltage will be appear across the C and D. Hence this is the formula. We got it. Is RS is equals to Vs. Already you know this formula. This is very important formula for this conversion of technique. Are some books they used to write like this. Vs is equals to, like this also you can write. This is a way of converting of non-ideal current source to the non-ideal voltage source. So this is very important way of derivation. So I can going to be use this over here. So same Vs of this voltage will be up here. Wait. Same voltage will be appearing here. Is nothing but a Is Vrs is nothing but a Vs. So that is the reason I wrote Vs is equals to Is Rs. Hope you clear about this session. Right. So this is the conversion of, let me write that name of the conversion. Non-ideal current source non-ideal voltage source. This is the one type of transformation. The transformation number is 2. Vision. So let me save it. So then let me move to the our PPT. So that's it. This is about the derivation of Vs is equals to Is Rs. Next, let's see with examples on our next slide. So let's read our problem. Find an equivalent current source to replace Vs and Rs. Please note on this. This is Vs supply voltage. and RS in the given circuit. So here observe this Vs is a, so you should replace this with Is and RS. So this is the problem. So you should find these two parameters instead of not changing this IL and VL. So you should remember this. You should not change this IL and IL. So before this change, should not change this IL and VL. So then you need to be convert like this. This is current source, and the resistance is going to be parallel, and this is RL. RL, that voltage is 6 kilo ohms is fixed, and the IL, if IL is given any current, that is also fixed, and VL across this load resistance also fixed. Then this is RS, you need to be find, and how much current is going to be sending from source, that is you need to be, this is the equivalent circuit. So here I'm going to be taking a lot of 2 to 3 different cases based on the changing of resistance value, means based on the RS, based on the changing of resistance value, how my load is going to be affected, right? The conversion is very easily, you can convert directly. I will show the conversion from here itself only. Let me remove this. Here you can find directly like this. Let me take this screen. From here, this is Vs, right? RS. How much current is going to be traveling? IL is equals to, load current is equals to Vs by RS plus RL, right? This is our formula, RS plus RL. How much value of resistor? 18 divided by 3 plus 6, 9 kilo ohms, means the current is 2 milliamps. 2 milliamps of current which is going to be following 2 milliamps. IL is 2 milliamps, right? Let's substitute this IL in our equivalent circuit diagram. What is our equivalent circuit? Means what is our equivalent current source for converting? This is the equivalent current source. Let me draw here. This is current source, and this is the resistance. Resistance also should not change, already you know, and this is my load. 6 kilo ohms. 6 kilo ohms, and this is 3 kilo ohms. Now this is Is. You don't know how much of current is sending from source, but you know only IL, right? What is IL? The current flowing through this IL. This load means load current. Already you know this value. Here you got it already. IL is equals to 2 milliamps of current is flowing. But how you are going to be find the source current? 2 milliamps of current is traveling. For the finding of source current, you should depend upon the CDR, means current division rule. How the current division rule is exhibits? Here, let me change my marker color. For the current division rule, already when the isolate the switching on the supply, the current is going to be divided into the 2 ways. One is current is traveling through this I3, means 3 ohms, this 3 ohms, and another current is IL. Now you know the current which is flowing through the 6 kilo ohms, you know, but you don't know the source current. So just write the formula for this current division rule for the 6 kilo ohms. What about the current division rule for the 6 kilo ohms? For the finding of current 6 means IL is equals to, means 6 kilo ohms. 6 kilo ohms current is equals to total current. Let me assume total current is Is into opposite value of resistance means 3 by 3 kilo ohms by total value of resistance means opposite of this 6 is 3 now. So then total value is 6 plus 3 k. The k is get cancelled. This means kilo ohms both get cancelled. 6 plus 3. But you know, for instead of is, you know the load, because for the knowing of this IL, then you can find the unknown parameters IS. So IL, what is the value of IL? 2 milliamps. If you substitute this 2 milliamps, means 2 into 10 to the power of 3 or 2 milliamps is equals to IS into 3 by 9. Then the value will be IS is equals to how much current is sending to the entire circuit? 6 milliamps. 6 milliamps of current which is sending through the circuit. Hence, by knowing of this 6 kilo ohms current, then you can finding the source current by using the CDR, current division rule. For this current division rule, I used to find the current as 6 kilo ohms. For that, for the finding of current 6 kilo ohms, I am making the CDR rule. For the finding of current 6 ohms, IL is equals to opposite resistance, total current into opposite value of resistance by total resistance. That is the reason I included IL is equals to IS into opposite resistance 6 ohms by opposite resistance 3 ohms by 3 plus 6 kilo ohms. Hence, I got source current is how much value of source current? I got 6 milliamps of current I received. So this is the way of transferring. This is nothing but a way of traveling of this current. But here, way of changing the voltage source means just I am changing this. Let me change the color, then you can observe easily. So just I'm going to be converting this point to this. That's it. Here my current should not change and the voltage should not change. For the while the 2 milliamps which is traveling through the 6, here the current flowing through this IL should not be changed. So that's what I want to mention in this session. And the VL means across this VL how much voltage will be present, means 2 milliamps into 6 means 12 volts will be present. The same 12 volts should be present across this here. So VL is equals, after converting voltage source to current source, the same voltage will be present. If you have any doubt, please check. 2 into 6 is 12, and kilo ohms, kilo and milli is get cancelled because this is 10 to the power of 3, this is 10 to the power minus 3, both get cancelled. Then the 12 volts will be appear across this load resistance. Hence, this is 12 volts, this is 12 volts, VL, IL. So I am going to be concluding this. VL and IL of voltage source is equals to VL, IL of current source. So this condition need to be satisfied. Means the power at, this is power, means power is combination of voltage and current. The power at output is should not affect. Always the power, constant power should be present before or after conversion. So this is what I want to discuss. But in our next slide, I am going to be change this resistance. How the changing of this resistance, how my voltage is going to be affected, how my input voltage is going to be affected by making the constant of VL and IL. Let me observe. I will repeat it again. By changing of this resistance of 3 kilo ohms, means I will take 6 kilo ohms, 12 kilo ohms, and then I will take 3 kilo ohms. After the changing of this resistance, how my input current is going to be affected. That's what I want to say. Right? Let's see. Here This is already we discussed in our previous slide only. In previous slide we discussed this only about this. Let me recollect your knowledge. Here I'm going to be finding of VL. Here I did only voltage division rule. Here I did the current division rule, right? Here itself only directly I find the voltage VL. But here what I did, I'm using this circuit for the making of current and all these concepts. But you can follow this procedure, or you can follow this procedure. So find the IL and VL, because this is the parts which we are going to be finding, VL and IL. For the finding of VL, you should depend upon VDR. This is VDR, voltage division rule. For the VDR, already the income voltage is there, 18 volts already is given, and this is the required value of the voltage, means resistance, by the total resistance. Then you will get 12 volts across this resistance. So here I why I follow the CDR means, in the next slide is the VDR. That is the reason I used one of the different method for the finding of VL and IL. I used CDR over here, but here I used VDR. This is directly you used by using this circuit before the conversion. So here I find the VL, and now I'm going to be find of IL. IL, the formula is VL by R. Already I know VL 6 kilo ohms. Sorry, VL is at 12 volts, and IL is a 6 kilo ohms. Then the value will be 2 milliamps. Hope it clear. Then we can find Vs also, means power of supply power is equals to load, power at load, and power at internal resistance. Means this is loss. Means P input is equals to P output plus P losses. This is the losses which is in the part of internal. So here you can find the power easily, because the power is nothing but a combination of voltage and current. For the finding of PL, means power at load, you can multiply with 6 and sorry, you can multiply with the VL and IL. Already you know VL 12 volts and IL is equals to 2 milliamps. Then you will get a power as 24 milliwatts. Here the 24, here 12 millihours, right? Because 6 plus 2 means to 12 milliwatts. Then 12 milliwatts, 6 to 24 plus 12 is nothing but 36 milliwatts is giving supply. So what I want to say is, let me remove this marks. So here I am giving the 36 milliwatts of power from the source. This power is going to be divided like this: 24 here output and 12 here. The 12 milliwatts power is wasted in the form of losses. This power is not utilized, but utilizes power is 24. Means this is the input power, this is the output power, this is the loss. So now, while the changing of this internal resistance, how my output is going to be affected, or how my input is going to be affected. So that what we are going to be discussing in our next slide. So this till now the example is still continuing. This is only what I want to say. This is only practical way of understanding the concepts. If you changing the value of the internal resistance, how my output is going to affected, or how my input is going to be affected, either maybe in the form of power or in the form of voltage and current. Now if in the parallel with the current source Rs is equals to 0. This is ideal case, right? Now you found the IL and VL in this voltage source itself. This is a voltage source. Now my job need to be convert this voltage source need to be current source without changing this IL and VL. That is my job. So here I don't want to change this IL, and I don't want to change the VL. Without changing this VL and IL, then I'm going to be change this IS and RS. How that my IS and RS is going to be affected. So now this is case one. Now I'm taking the infinity value of resistance. Means infinity value of resistance means there is a no resistance in between RS. Then how my IS, how my RS is going to be affected. My RS is infinity already. This is a defined value. What about the IS? because this is RS now. There is no value of resistance here. Then the total current is traveling till the load RL. Then IL is equals to IS. You can write like this: IL is equals to IS. Then for the finding of VL, the same 2 milliamps into 6 coulombs. Then 2 volts will be appear. The total power means the PL is equals to PIS. Power at input is equals to power at output when my resistance is infinitive. So you should remember, when there is a no value of dropping of resistance in the internal, my input power is equals to output power. This is case 1. Case 1 means when the input resistance is infinitive, the total current is traveling to the load, then the input power is equals to output. There is no losses. This is the ideal case. Now case 2. In case 2, I use 20 kilo ohms instead of my value of resistance 3 kilo ohms. I use 20 kilo ohms. How this is going to be happen? While I am giving the 20 kilo ohms of this RS, RL, VL, IL is fixed. Please remember that point. RL, VL, RL, IL, VL value should be fixed. This value should not change. So RL is the same value, 6 kilo ohms. Now I'm going to be find the value of IS, because I changed the RS now. So my IS is going to be affected because I changed the RS. My IL is going to be, my IS is going to be affected. Then I use the current division rule, CDR rule. IL is equals to, for the finding of current through this RL load, IL is equals to the total current means IS into IS multiply with opposite value of resistance RS divided by RS plus RL. RS plus RL. Then, but I know the value of IL 2 milliamps, and I know the value of RS, and I know the RS RL, but I don't know the value of IS. Then for the knowing of IS, I send this all the part to the left side. Then my equation will be look like this. Then here I'm going to be find the IS is equal to RL plus RS. Then I know the IS value is 2.67 milliamps. So here you need to be observed clearly, 2.67 milliamps. In our case 1, here the IS is 2 milliamps, right? But in case 2, when I'm changing the value of resistance, means 20 kilo ohms, my IS value of my drawing of current will be increases, right? So here, while the changing of IS, my power is also going to be affected. Earlier my power is just 36, right? Sorry, not here. My power is 24 milliwatts, because my input power is equals to output power when my RS is equals to infinitive. But here in my case 2, I use it to some value of resistance is 20 kilo ohms. Then my power is going to be affected. For the finding of power of this IS, so you need to be considered power of RS, power of RL, power across RS, power across RL. So this is RS, this is RL. RS for the finding of power across VL. For the RL, you need to be considered VL and IL. For the finding of power across RS, you need to be considered voltage across RS and the current through the RS. Then for that, 12 volts, 2 milliamps, already this values is given, and this VRS is same because this is both are parallel now. The same voltage will be appear across this VRS. Then 12 volts. What about the current? Already this is a sending current. This is the delivered current. This is the remaining current. 2.67 minus 2 milliamps. Then the 0.67 into 12. Then you will get 32 milliwatts. Here the observe the power. When the infinity value of resistance 24 milliwatts. When the value of resistance is slowly decreases, means infinity means there is a millions and trillions value of resistance is slowly decreasing to the kilo ohms. My power is going to be consumed, right? More, right? Next, this is case 2. Next, I'm going to the case 3. Slowly I'm decreasing the value of resistance 20 kilo ohms to the 6 kilo ohms. How my power consumption is going to be affected? For the 6 kilo ohms also same. I should not change the value of IL and RL, VL. So these values are fixed. IL are because this you should not change this part. So for the finding of IS, same. Already these are the noun values. This is only unknown values. You should substitute these noun values RL plus RS. So after substituting, you will get 4 milliamps. So here the current again increases 4. If you are using this, one moment. We observe here the current is slowly increasing based on the decreasing value of resistance. Please try to observe this point. So on your next class, you will get full of clarity by observing this value of resistance. So here, same way, you are finding the PIS means total power consumable for the giving of this. But here the power rate consumable of this load is not changing. Means 24 milliwatts power is not changing of the any case. If you changing of this value of the resistors, only the power is going to be affected. Means 48 milliwatts. Now let me move to the next slide. On the next slide, I completely move to the directly my internal resistance, that is 3 kilo ohms. This is 3 kilo ohms. Now my total power is 72 milliwatts. This is same steps. I'm not here to discussing again the same steps because you can follow those steps in our previous slide. So you can follow those steps for the finding of IS. So here IS is 6 milliamps. So now let you observe clearly how my IS is going to be changes. So let me draw that. Let me change this. First, initially I took it as my resistance is initially this is my resistance is infinitive. While I am resistance is infinitive, my power, let me observe the power. Right, power is 24 watts and the current, this is resistance means RS. R is fixed. And what about the VLIL also fixed? Means power at load. Sorry, let me find the power at source. And this is input. Power at source, sorry. Power of RS. Don't require the power of RS, power at source. This is power of RS. Power of RS is not mandatory. Let me add that point as a power of source. Power source and the IS. IL. Right? So right. So first case one, I took it as an infinity. For infinity, my input power is same as output power, 24 milliwatts. 24 input power is same as output. Let me add my output power also. P out. Output power. 24 and my output power also same 24. Whatever the input current, IS and IL both are same. How much value of current is 2 milliamps, right? 2 and 2. Now I change the value of resistance, that is, instead of in infinity I use 20 kilo ohms. While I'm changing the 20 kilo ohms, now my value of resistance is 20 kilo ohms. Then whatever the input power is changed, how much value is changed? Input power is 32. What about the input current? Input current IS also changed. Here my input current is 2.67. 2.67. My load current is not changing, same load current 2. Since the load current is same, my output current also same, output voltage, output power also same for the for this output power also same, 24. Next, for the changing of my resistance 20 kilo ohms to 6 kilo ohms, let me change to 6 kilo ohms. For this, what about my input power? It changed 48. What about my input current? IS also changed 4 milliamps, but my output or load current is not changed, 2 milliamps itself only. Means since output current not changed, the drawing capability of power at output load is also not changed. So 24 milliwatts. Now the last point is 3 kilo ohms. So now after the changing of 6 kilo ohms to 3 kilo ohms, my output power is 72 milliwatts. 72. By my input current is 6 milliamps here, and my load current is not changed. Two milliamps. Since the load current is not changed and the output power also not changed, 24 milliwatts. By observing of this table, you should understand very important points. So let me understand this table clearly. Please have a look, at least 2 to 5 minutes. Please observe these points and what conclusions you made after the observation of this table. Please try to observe this table. Very important analysis. So observe this table very clearly. See, after observing this table, you should conclude a few more points. By changing the resistance, by changing the value of resistance means by decreasing the value of resistance, my power is going to be increases. Please observe this point clear. How you are showing in terms of equation like this? P is equals to always I square by R, like this you can show. Means while I'm changing the value of resistance, means when the resistance is decreases of the input supply, my power is increases, like this. See, observe this infinity from 20 kilo ohms to value decrease 3 kilo ohms, but here the power is increases. And same way, the input supply also increases. See, input supply also increases. By decreasing of the value of this 3 kilo ohms, the power is going to be increases, input supply is going to be increases. Since as per our rule, after the changing of any conversions, the output elements should not be affected. That output elements are VL and IL, which affects output power. So by observing this table, I concluded these points. Current and power that the ideal current source need to generate in order to supply the same current and voltage to the load increases as decreases. Note, Rs cannot be equal to 0 ohms. If Rs is equals to 0 ohms means, let me think, if this is 0 ohms means there is no value of resistance here, means even though the load is exists some value of resistance, the current will not flow through this load. Why? Because current always choose the least resistance path. Instead of flowing through the current flow through this element, the total current is drawing by this path only. That is the reason I included this point. Note, Rs cannot be equal to 0 ohms. So, and the power dissipated by RL is 50 ohms of the power generated by the ideal current source when Rs is equals to RL. This point means, here observe here, when 3 kilo ohms is there, right? There is 3 kilo ohms. When Rs is equals to RL, here this point means, let me add my marker. So this point means the power dissipated by 50% of the power generated by the ideal current source when Rs is equals to RL. When load is equals to source means the output load is equals to input resistance. Then the 50% of power is supplied by load itself. That what I included by ideal current source itself. The power dissipated by load itself will be consumed 50% of power. Here already proved, because Rs is 6 kilo ohms, my RL also 6 kilo ohms here. If you observe my initial circuit, my RL is 6 kilo ohms. Then that is the reason I used different cases. So 6 kilo ohms is equals to 6 kilo ohms. The 50% of power is delivered, is dissipated by the load itself. Here the proved the 24 and 24. 50-50, the 50% of power dissipated by the load itself only. So this is the important point for your examination, means multiple sequence question, multiple choice question. This is one of the most important questions in your examination point of view, which who are the preparing of the competitive exams. This when that load is 50% of the power is consumed, in which case when the load resistance is more than the internal resistance, or load resistance is less than the internal resistance, when the load resistance is equal to the internal resistance. These none of the above. Always you choose this C, because Rs is equals to RL. In that condition only, the 50% of power is dissipated by itself, load itself only. Hope you clear. That's it. This is today class. Hope you understand these all the concepts. And this is, please try to remember this point. This point, conclusion of my all these cases, whatever I discussed, this case 1, case 2, case 3, and case 4. On this all these 4 cases, I concluded by stating this point. Please try to note down this point. And so I'm going to be signing off. Thank you. Bye bye. Have a good day.